welcome to your home school. This is your next session of your 9th standard mathematics NCERT or CBSE board. First chapter, number system. In this chapter, in our last session, we have completed up to 2 exercises. In this session, we are going to start your third exercise. So before starting this exercise, I am going to discuss your 4 points here. As we have seen our basics. What are the basics, children? We need to get from some basics from you. What is that? Decimal expansion. When you are doing any division, suppose if you get a remainder 0, then which type of a decimal it is called as? The remainder, if you get 0, that decimal where you get in your quotient, that decimal we call it as a terminating decimal. So, suppose if you are not getting any quotient 0, any remainder 0, means if your division is never ending, so it continues so on. So, what you are going to say that type of a decimal is called as a non-terminating decimal. Children, try to understand here. When you get in your division, if your remainder is 0, when it is ending your division, you get a remainder 0. Then that type of a decimal you get in your quotient is called as a terminating decimal. When you divide any number, if you won't get any remainder 0 and your division continues, so never ending quotient you are going to get. Then that type of quotient is called as a non-terminating decimal. See children, in non-terminating decimal also, there are 2 types. Non-terminating decimal, suppose terminating 1.375 I will say. So 1.375, there is an end for the decimal. So if there is an end, it is a terminating. Suppose I am going to say you 1.347328954 like this. Up to infinity, there is no end for this decimal. Then what is this type of a decimal is called as a non-terminating decimal. And one more type of decimal here, children. Suppose I say you 2.333333 means where the 3 ends we don't know. What am I saying here? 2.33333 means the 3 decimal is repeating again and again. So repeating we call it as a recurring. Repeating decimal is also called as a recurring decimal. So 2.3, how do you write repeating decimal here, children? You may write it as 2.3333 so on. That can be written as 2.3 bar, where 3 digit is repeating, or you may put with a dot. So this type of a decimal is called as a non-terminating recurring decimal or non-terminating repeating decimal. Suppose if your decimal is ending here like this, children, then what is this type of a decimal? It is a terminating decimal. Terminating means there is an end. Now one more, 1.34732 so on. I don't know how many numbers are there and where it ends. So this type of decimal, what do we call this? It is a non-terminating, non-recurring decimal. See here, children, we can convert other decimals into rational. What are those? Whereas if you have a terminating decimal, non-terminating and repeating decimal, we can convert. But whereas non-terminating, non-recurring decimals, we cannot convert into rational number. Those type of numbers are always irrational. Irrational in the sense it is followed by a root. What is a root, children? Look here. How do you say this root 3 or root 5 or root 7? What do we call? This is a surd. It is an irrational root of a rational number. What is this, children? It is an irrational root. Root itself is a irrational of a rational number. So when you get a decimal, if it is non-terminating, non-recurring, those type of decimals are all called as irrational numbers. Only irrational number value will be that type of decimal. Remaining all the types of decimals we can convert into rational numbers. First of all, what is a real number, children? Real numbers is a combination of rational and also irrational numbers. Okay, let's start with our third exercise here. What's your first main? Convert the rational numbers into decimal form and say which type of a decimal it is. Either it is a terminating decimal, non-terminating, recurring, non-recurring decimal. You should identify by doing the problems. Okay, children, let's start the problems here. Look here, first problem. 36 by 100. 36 by 100. Directly we can write, children. No need of doing any division. 100th means after 2 decimals you put a point. That is decimal point. Look here. 3, 6. From right side 1, 2. Put a point and write here 0. What's this value, children? 36 by 100 can be written as 0.36. 0.36, there is an end of this decimal. So which type of a decimal it is? It is a terminating decimal. Terminating decimal, children. So there is an end for the division. Therefore, it is a terminating. Look to the second one here. 1 by 11. 1 by 11. How do you write here? This is the fraction. Numerator, denominator. And when you divide, you call this number as a dividend. And this is divisor. So let's do the division here. 11. So look here, children. When you start division, what happens in 11 table? Do you get anywhere 1? No, we can't get. So for that purpose, what we are going to do here? In your answer, put 0 point and put a point here. Go on writing how many zeros you want. That many zeros you can extend. When you are doing division, what you are doing here, children? 0. Put 0 and a point. So how many zeros you want, you can write here. Now, so you can forget about this decimal now, right? 11 ones are 11. So 10 you won't get in 11 table, right? 100 you see here. Okay, I have removed here point and I have kept here, right? So 0 point. Now 3-digit number you see here. So now 11 9s are 99. 100 minus 99, how much, children? 1. Again, drag 2 zeros. 1 0 you can't. Anyhow, you have kept your point, right? So how many zeros you want, you can drag. So now again 100. 11 table, where you get 100? Same, 9s are 99. 100 minus 99 will be 1. Again 0 0. Again 9. So on it continues. Yes or no? So now what you can write? 1 by 11 is equal to 0.9999, so on. There is no end for this division. So if you increase zeros, your answer in your quotient, increased 9s you are going to get, but there is no zero remainder. This division never ends. So this type of divisions, we call it as a non-terminating division. And this type of a decimal is called as a non-terminating, repeating decimal. So look here, children, this type of repeating, how can you write? 0.9 bar, where 9 is repeating, right? 0.9 bar, this decimal, this division, and this decimal is called as a non-terminating repeating decimal. Let's see the third one here. Third one is in the form of a mixed fraction. Mixed fraction, what we need to do? First, convert into improper fraction. Then you can divide. So now, how do you convert here, children? First, multiply these two, then add. 8 fours are 32. 32 plus 1 will be 33. So if you want clearly children, you can go with this 8 into 4 plus 1 by 8. That will be 8 fours are 32 plus 1 33 by 8. So now we need to divide this rational number, that is 33 by 8, and get the decimal value. After getting the decimal value, we need to say that it is terminating or non-terminating. So let's start here division. 8, 33. So 8 table where you get nearer number to 33. So it is 8 fours are 32. 33 minus 1 is 33 minus 32 is how much children? 1. So now what you need to do? Put a point, right? So these type of division better go on doing like this, 4 point. So if you put a point, so what happens here? You can go on increasing your zeros until you get a remainder 0. So now 33 minus 32 will be 1. So observe here carefully children, have to do this type of division. 33 by 8. 8 fours are 32. So now 1 is remainder now. You should extend this division. You have to get a proper decimal here. So for that reason, put a point here and write how many zeros you want. You can, right? Now 4 point. So 8 table. Just see here, drag this 0 down. 8 table where you get 10 children. 8 ones are 8. Then now 10 minus 8, it will be 2. Again drag this 0 down. 20. So next, which is the nearest number in 8 table? 8 twos are 16. Then 20 minus 16 will be 4. Then again drag one more 0. That will be 8 fives are 40. Yes, there is an end for this decimal. So look here children, now these two zeros, no need. How many zeros you want, you decide while doing the division. So now what is this answer here children? 4.125. 33 by 8 will be 4.125. That means there is an end for your answer by getting your 0 remainder. So this decimal is a terminating decimal. We write this decimal as a terminating decimal. Terminating decimal. Let's see your fourth problem children. For this fourth problem, I have written here 13 table. Okay, it is easy to do the division for you. So now 3 by 13. This is dividend, this is divisor, right? So now let's start your division here. 13, 3. So let me start my division like this. 13 table, do you get anywhere 3? No. So what we need to do? We need to start with a 0 point. So now, come on, let's take some number of zeros. Okay. So now, 13 table, do you get 30? Look over here. No, 13 twos are, it will be 26. So that will be how much here children? 30 minus 26 will be 40. Now again, 30 table, where you get 40 nearer? 13 threes are 39. 13 threes are 39. Now, 40 minus 39 will be 1. So now what you do here? Drag 2 zeros. 1 0 means what happens here? Only 10 it will be. Right? You need to take 2 zeros. 13 table you won't get 10. So one more 0 if you drag, what you need to do? You need to put first 0. Why? 13 zeros are 0. 10 plus 0, 10. Then next 0 you are dragging. That makes 100. Okay, that is the reason we put a 0 there. So now 13 table, where you get 100 children? Look here, 13 sevens are, it will be 91. So now 13 sevens are 91. Okay, so 100 minus 91 will be how much? It will be 9. Now again drag another 0. So that will be, which is nearer to 90 here children, observe here carefully. 13 6, it will be 78. So now what you need to do here, you need to subtract. 0 you can't, so take a carry. 10 minus 8, 2, 8 minus 7 will be 1. It will be 12. So now drag one more 0 down. It will be 120. Where you get 120 children here? 13 9s are 117. Right here, 13 9s are 117. Right? So now you need to subtract here. That will be 3. So here it is 3. Again what I need to do? Take some more zeros here. So drag 0 down. That will be 30. Look here, 13 table. Where you get 30 here? 13 2s are 26. 13 2s are 26. Okay, so 30 minus 26 is how much? 4. Right? Look here. Let us start our division here. Or see here, 4 means again if you drag 0, what happens here children? 40. So from where here it continues. That means look here children, from here same division will be continued from there. Right? It means how much is this answer children? 30769, like this 30769 means 769. Now observe here children, you go on doing your division, it never ends. It is repeating. See here, after 0.230769, 230769 means this 6 decimal places again and again repeating. But it is no end here. So what you are going to do here children? Therefore 3 by 13 is equal to 0.230769 bar. Why? The 6 decimals is repeating again and again. So which type of a decimal it is children? It is a non-terminating repeating decimal. Therefore, what you are going to write? Therefore, this decimal is non-terminating and repeating. Non-terminating and repeating decimal. See here children, in your fair notes you need to do this decimal. Up to here you need to do the division. Okay, then you have to end your problem and say this type of a decimal is a non-terminating and repeating decimal. Let's move on to your fifth problem. What's your fifth problem here children? 2 by 11. So let's see here fifth problem children. It is 2 by 11. What you need to do? You need to convert this rational number into decimal expansion and check whether the decimal expansion is a terminating, non-terminating, recurring or non-recurring. You need to identify after doing division. Let's do the division here. 11, 2. Okay, in 11 table we won't get 2. So what you need to do? 0 point and then you need to extend zeros. Okay children, so let's put here 4 zeros. So now 11 table, where you get here 20, 11 ones are 11. Okay, 11 ones are 11. What is 20 minus 11 children? It will be 9. 9, take 1 0 down, 90. Then in 11 table, where is the nearest number to 90? 11 8s are 88. 90 minus 88, it will be 2. Drag one more 0 down. Then again, 11 table, where you get here? So 11 ones are 11. Again 9. Drag this 0 down. 11 8s are 88. 90 minus 88, 2. Then again, so what you can observe here, children? Again, it is a repeating you are getting. So look here, observe here, up to here. From here, again it looks like this, 20, 11, 90, 88. Children, don't you feel that it is repeating? Yes, it is repeating. So what is this? 2 by 11 is equal to 0.181818, so on. There is no end for this division. So what is this decimal expansion called as, children? It is a non-terminating. There is no end, right? It is a non-terminating repeating decimal. So therefore this can be written as 0.18 bar, and therefore this decimal expansion, therefore this decimal expansion is non-terminating and repeating decimal Okay, with this we are going to end this answer. So now coming to your sixth problem, children. 329 by 400. How do you do this, children? So now look here carefully. 329 by 400. Let's start the division here. 400 is a divisor. 329 is a dividend. So observe here, children, 329 is less than 400. So what we need to do? Put 0 point, right? Go on increasing zeros here, right? So 400, in 400 table, where you get the nearest 3290. So where you get here, children? I think 408. 408 how much here? 3200. Will you accept? 408 3200, which is the nearest number for this. So now if you subtract, this will be 90. Drag 10 down. In 400, where you get 900, children? 400 table, 400 2s 800, right? So write 2 there and write here 800. 900 minus 800 will be how much? 100. Drag one more 0 down. Okay. Now 400 table, where you get 1000. Where you get here? 400 2s 800. So now 1000 minus 800 will be 200. Drag this down. This will be how much now? 2000. 400 table, where you get 2000, children? 405s. 405s 2000. Therefore, there is an end for this division. End means we got a remainder 0. So observe carefully here what we are going to say. This division we get a decimal expansion of, there is an end for it. There is an end means this decimal is a terminating decimal. So this decimal expansion, we are going to write that 329 by 400 is equal to 0.8225, and therefore this decimal expansion is terminating decimal. Okay. With this, we are going to end our session, children. Tomorrow in our next class, we are going to continue this exercise. Thank you all.